Here are some of the equipment you might utilize when you want to transport 4K video over Ethernet. Let's put it together. I'm going to show you how to use a physical network topology diagram to assemble and configure a small AV over IP sandbox or bench test network. Then we're going to pass a video signal over the IP network. In a lot of cases, the IT department will give you the physical topology of your network. It'll show you the room locations, cable runs, and the physical ports on your switch that you'll be plugging into. Hopefully, you are working with the IT department, but sometimes you may need to create these documents yourself. It'll also show you if there are any patch panels in your rack elevation drawings. But you will have everything you need for all the cable connections and all the devices that you will be connecting into. You should also get a logical topology. This information will generally contain an abstract illustration of the system at a functional level. It will contain higher level information that you will utilize to provision the system. This includes things like equipment lists, IP addresses, MAC addresses of your network interface cards, physical and maybe even logical ports, or even the configured VLANs of the switch. Anything that will be needed to provision the network will be included within this logical topology. The information may come in the form of a diagram, a document, or even a spreadsheet. The logical topology should come from the IT department, like I said, but it should always be part of your documentation. Here we have two 12-port multi-layer AV switches. Sometimes multi-layer switches, like these, are also called layer 3 switches. These are fanless, which is a valuable component in an AV installation where we want silent operation. Now this switch also supports PoE. I verified that the switch supports the power requirements of both the encoder and decoder we will be using. For production, you will need to conduct PoE power budgeting. We sent this model to the IT department weeks ago, and it was certified by their IT security personnel to be within their parameters. Like many larger switches, this one has two SFP ports that will enable us to use other physical media, like this multi-mode optical cable. With this SFP and cable, our signals can travel up to 550 meters without amplification. Similar SFPs and optical cable can travel distances measured in kilometers or miles before amplification would be needed. We'll also be using a traditional twisted pair copper category cable. You should avoid anything less than a category 6A, although for lower bandwidth, Cat6 or even Cat5e may also work. Most equipment manufacturers will recommend a prefabricated cable, but always check with their specifications for the usage. Here we have an AV encoder or transmitter that will convert the serial HDMI signal into a compressed, packetized AV over IP signal that is sent over the Ethernet. And the decoder, or receiver as it may also be called. This sits at the destination and takes the IP information, and it'll decode it into an HDMI and across the cable to this small 4K display. In the industry, you might find that AV over IP transmitters are often called encoders, and the receivers are often called decoders. Don't let this confuse you. Just verify with the manufacturer that you do have the right products. We have a laptop to put on the LAN and configure devices. It only needs a network port. That way we can actually connect it to the devices for configuration. To get started, we need to configure these switches to work together within the same LAN. Usually switches from the same manufacturer will have the same management or default IP address, and you can find this information within the user documentation. Since we have two switches here on the same network, we will need to change the IP address of one so that the addresses do not conflict with each other. Before we make these changes, we need to look at our logical topology diagram to see what we want to change this IP address to. We will then use the PC to log into the switch's management interface using its default IP address. And then we can change that IP address to the new one that we got from our logical topology diagram. To do this, we will change our PC's IP address to an address on the same subnet. It's a safe bet to take the switch's default IP address and just add one to it. In this case, any valid IP address within the default subnet. Generally, you can set the subnet mask to 255.255.255.0. For configuring the equipment, this will work for most of the time. Now we are ready to connect our PC to the switch. We navigate to the management interface and log in. Remember that we got the new management IP address from the logical network topology diagram. And in this scenario, that is 192.168.0.4. Some configuration changes to network devices will require a reboot. Changing the management address is one of these. After the reboot, you will need to log in to the new management IP address. The next thing you will want to do is to set the administration password so that it complies with the IT security requirements that they provided. Changing it from admin to whatever password and username the IT department gives you. To work with AV over IP, there are a few other settings you will need to change. Be sure to review the documentation from your equipment to see exactly where you need to change. These are two typical settings that need to be changed. The MTU needs to be increased and the multicast needs to be enabled. Not all switches support these features, so make sure to check your switch specifications before you include them in your network. The first is MTU, which stands for Maximum Transmission Unit. Now MTU sizes above the standard 1500 bytes are referred to as a jumbo frame. Now this means that we are making the Ethernet frame payload bigger. This allows more information to be sent on each Ethernet frame and reduce the amount of wasted bandwidth that we could have had. In other words, you get more payload per packet header. The other configuration change you will need to enable is multicast. This allows you to send information such as your video from one source to many destinations without using all of the bandwidth on the switch. You will also need to enable IGMP protocols that support multicast as long as your switch allows that. Sometimes the configuration will be listed under IPMC. And not to be a broken record, but the specification settings and location for your switch and device configurations will need to be looked up in the system documentation. For future technical support, make sure you save and document your switch configuration changes. This could help you in the future. Now, you need to repeat the same setting changes for the second switch. In larger enterprise environments, all the network hardware will be managed at the command line interface. We refer to this as the CLI. If you plan to work on network equipment from the largest manufacturers or in an enterprise network, you will want to master manufacturer-specific CLIs. For network administrators, the CLI is the most efficient way of making changes. And making bulk changes to network hardware is much easier. So before we get started connecting the switches, we'll want to label our switches. Make sure to check the project documentation to see how your customer or the IT department wants the equipment labeled properly. Now we can start connecting the devices according to that physical topology network diagram. The first thing we want to do is to bring up the fiber link between the two switches. As you can see, this is an 850 nanometer SFP that is rated to reach up to 550 meters with multi-mode fiber. Now we need to look at the physical network diagram to see where we want to plug in the SFP, which according to the diagram is port 11. Here is a multi-mode duplex cable. We can use the short jumper, or we can use up to 550 meters of cable, which for those of you not familiar with the metric system is right around 1,800 feet. Not only does this optical cable increase our reach, but it also provides a transport method that is impervious to both EMI and RFI interference. It's also important to avoid getting any of the fiber optic or the SFP dirty. Now, for this reason, you'll notice that the SFP comes with a rubber cover and the fiber optic comes with little round caps that are dust covers. Now pay attention to the optical cable's bend radius. Specifications will let you know what the maximum bend radius is. Bending too sharply will damage the cable since they are made of either glass or a very fragile plastic. Now this cable has about a 1-inch internal diameter bend radius. All right, so according to the physical topology diagram that you should always reference, the optical SFPs should be plugged into port 11. Now let's remove the SFP's cover and the cable covers. Now pay attention, these little metal clips that hold in the rubber covers. Now we can turn on the switches to look to see if the link lights actually come on for the optical ports. Good, they came on. Now we can connect our encoder and our decoder. We will need to assign IP addresses based on the logical network diagram.
We can see that the diagram assigns 192.168.0.51. Now we're going to assign this to the encoder, and then we will assign 192.168.0.101 to the decoder. Some network configurations may specify that you configure the device for DHCP so that the IP address can be set by the network. Now we need to assign their IP addresses. Notice that we did not change the gateway or the subnet mask. These were already configured correctly. Then we will associate our sources with one or more displays. With more sources and displays, these associations can become more complex. This process is manufacturer specific, so look at the documentation to verify the process.
Once we get the encoder and decoder's IP addresses assigned, we are ready to attach them to our network. We will again refer to our physical topology diagram to see which physical ports the IT team has assigned for us to connect to for both our encoder as well as the decoder. So I can see, according to the topology, the encoder is going to plug into switch number 1 on port 3. So I'll go ahead and connect that now. And now I'm actually going to connect the encoder into its LAN port number 1. From there, I can now connect switch number 2 to my decoder. So according to the topology, I'm going to connect this into port number 4 of the second switch, which I will do now. And they're connecting it into the actual decoder into its LAN port number 1. So you'll notice that both devices should automatically turn on. This is powered by the switch using Power over Ethernet. To configure your AV over IP devices to pass video traffic, once again, you should always make sure you take another look at the product documentation provided by the manufacturers.
For our initial setup, we will use the manufacturer's PC client software. When you put the system into final production, there are additional third-party control options available for management and configuration of the system. So we are going to need to associate the encoder's IP address to the decoder's IP address. In the PC client, we link or associate the source IP addresses to transmit encoded HDMI video and audio to the destination decoder and then out to the display.
In our current configuration, we are transmitting compressed 4K video and audio stream that comes from this media player over HDMI and then across our configured network, through all the way to this decoder here, and then back out on HDMI to the 4K display. Now that's our quick assembly of a little bench test of our LAN configuration. There are a few key things that you need to remember when you're doing this. Always refer to the product documentation. Different manufacturers have different methods for the initial setup, like IP address assignment. They also use different processes to associate display sources and destinations. Make sure to keep track of the configuration settings and the specifications of the equipment that you're using. You will need to inventory everything before you get started. Logical network descriptions or diagrams is where you will find the higher level information, like your IP addresses, subnets, applications, and some protocols. And the physical network diagram is where you'll find the cabling and locations, your port assignments, layer 2 physical equipment like the switches, racks, and patch panels. You can also find the buildings and rooms the equipment will be living in. IT will expect you to precisely follow the network diagram that you were given.